Let's take a look at this problem. We get limit as x approaches -3 of 1/3 minus 1 over x plus 3 all over x. Okay, and we'll fill out this table to help us figure out what this limit is equal to. You can read my writing. Okay, this one's a little bit tricky, and I like this one to include because it really demonstrates how to put things in your calculator. Remember, if you got more than a single number or single variable on top and bottom of your fraction, then you have to put parentheses around it. Well, this is we've got a big fraction here, so obviously we've got more than a single variable, single x up on top, or a single number. So you have to put parentheses on it. Now the 1 over 3 is fine, but the 1 over x plus 3, notice I have more than a single x or single number down here in the denominator, so I have to put parentheses on the x plus 3 when plugging in. So that's how we're going to plug it in. Okay, so I'm going to press my y. Oops. Press my y equals. Press my clear. I'll do beginning parentheses for the top part. That's this red. 1/3. It's 1 divided by 3 minus 1 divided by, and then we want the beginning parentheses around the x plus 3. So beginning parentheses, x plus 3, closing parentheses, that would be my closing blue one, and then I need for my red. So I do a closing for the red. And then divided by x. Well, let's make sure our table setup is correct. So I do second window to go into table setup. Your independent should say ask. If it doesn't say ask, down arrow to that line, right arrow, put your flashing cursor on the ask and press enter one time. Now go to my table, so do second graph. You may or may not have numbers there. I'll clean up mine. And we want -3.1. And we get -3.33. Next one is -3.01. And we get -33.33. Then -3.001. And we get -333.3. Then -2.99. 3 nines. And we get positive 333.33. -2.99. And we get 33.33. Another 3 actually, but doesn't matter. -2.9. And we get 3 point, and then a bunch of 3's. I said it doesn't matter, and you said, well, that's kind of weird. Why do you say that? Well, if you right arrow over, and then you up arrow, you see there's a whole bunch of 3's there anyway. So I'm not writing them all down. 3's keep going forever. So if you want to see how more decimal places, you can always right arrow over this and see it. Okay, let's look at it approaching from both sides. Let's look at this. Going 3 to 33 to 333, presumably the next one, if I did 4 nines, would be 3,333. So this is increasing. It doesn't seem to be converging upon anything. And over this side, -3 to -33 to -333, this is like going the other direction. So they're not converging upon a value. If you're looking at it as approaching from the left side and from the right side, and they're not agreeing, they're going to different values, then your limit does not exist. It has to agree coming from the left side and from the right side. Now I'll write D and E for does not exist. That's your answer.